So guys, picking up from the last video we looked at, where we ended up looking at the end of the aliphatic hydrocarbons. We'll look at for now. Essentially, they're hydrocarbons that are not aromatic. So I'll show you what that is meant by today. But yeah, so we looked at alkanes, alkenes and alkynes, and now we're going to look at aromatic hydrocarbons. Now there's something interesting about them, and we'll go through briefly, and then we'll look at it again next year. But for now, we'll have a look at aliphatic hydrocarbons are organic ones that are open chains of carbon atoms or rings that have similar chemical properties. That's essentially what we've looked at. So now we haven't looked at chloroalkanes. Or cyclohexanes I should say, but we looked at alkenes. We didn't look at cycloalkenes, but we looked at alkynes. We looked at alkanes. So you can have cyclic ones where one of the hydrogens is removed, or two hydrogens are removed either end of one of the alkanes, if you like, and makes a ring structure. So there's a hydrogen, and like off each one of those there is off here there's a hydrogen and the second hydrogen, because at every corner there's a carbon, you see. So that's called cyclopentane, because it's 1, 2, 3, 4, 5 carbons. And if you notice the one that's missing, what's missing here is, normally if you just had pentane, you'd have a hydrogen at either end of the chain of carbon atoms, if you like, whereas this time, instead of at a hydrogen, it's bonded back around to another carbon. But every corner here would have two hydrogens off it. So it is an alkane, a special type of alkane, and that it is cyclic. Now you can't get much closer than 4, they won't 5 cyclopentane, because essentially if you think about it, if you were to wrap that around the ring of 4, the atoms obviously are made out of electrons that repel each other, so there's ring strain there, and the ring effectively breaks open. So cyclopentane can be formed. Cyclohexene is used a lot in the laboratory. Again, it's hexane because if you were to count the number of carbons, there'd be 1, 2, 3, 4, 5 and 6. So there's 6 carbons around in that ring structure there. And then also off each one of those carbons, as well as each carbon being bonded to 2 other carbons, is bonded to 2 hydrogens, giving you the 4 again, 4 bonds. And then we looked at alkenes, and we also looked at alkynes. There's cyclohexene. You see there's only 1 hydrogen off here, and 1 hydrogen off here, and then there's 2 off these. And each corner stands for a carbon. So that's done a lot in university, in that you kind of stop drawing the C's so much, you just cross, especially in organic chemistry or that, the corner is assumed to be a carbon, and if nothing else is there, it's the 2 hydrogens, and if 1 double bond is there, well, you think about it, that carbon has 1, 2, 3, 2 bonds from the double bond, 1 from that single bond, and that gives rise then, only 1 hydrogen can be off it right there. Think about that, giving you 4 bonds. You know what it is. Carbon has 1 bond that way, 2 that way, and that means it only has 1 bond left for a hydrogen. So you end up, so that part, if you like, is that one in there. It's also that one there. Whereas down here you have a carbon, just like the ones above, bonded to 2 hydrogens, because that only has 4 bonds. If you take that out, it has 1 bond to 1 other carbon, 1 bond to 1 other carbon, and then it would leave 2 more bonds to give it the octet again, or the 4 bonds. And then the alkenes as well, or alkynes are the last family we looked at. But just aromatic hydrocarbons, we don't look an awful lot at it at Leaving Cert, but I'm going to show you what makes them so special now. Benzene is probably the most famous, or is the most famous aromatic hydrocarbon. It used to be added to petrol, but it's a carcinogen, so they stopped adding it to petrol. It's got to do with the improving a thing called the octane number of petrol, but it's carcinogen, so we don't want that coming out of exhaust fumes. Methyl benzene or toluene is used in laboratories. So benzene is not used for the reason that carcinogen effectively means it causes cancer, so we don't use that. But toluene you can get in the laboratory, and it has very similar chemical properties to benzene, so this makes it quite useful. Now I'll show you why exactly benzene is so special. And look at, for leaving cert, really we focus on the idea that an aromatic compound is one that contains benzene. So if I was to draw the structure of benzene, it has 6 carbons in total, so that will be 1, 2, 3, 4, 5, and 6. You have to forgive this diagram now. But there's the 6 carbons. 1, 2, 3, 4, 5, 6 in a ring. Now, you see there's double bond here, double bond here, and double bond here. So there's double bonds around. Now let me draw that again altogether. See the carbon, carbon, carbon. So that's if it was all single bonds. But there's actually a double bond here, here, and here. And then if you think about that carbon already has 3 bonds. Look at 2, and when I say that carbon, maybe I should use the highlighter pen. But if you look at this carbon, it has 3 bonds. 1 single bond there, and 2 involved in that double bond. So it can only make 1 more bond to a hydrogen. Likewise for this carbon, you look at 1, 2, 3, 1, 2, 3, 1, 2, 3. So each one of them can only make 1 other bond to 1 other carbon, or 1 other hydrogen I should say, so it can, or carbon, but in this case benzene to a hydrogen. And that gives you that structure right there. So they're all bonds to hydrogens. And now you have yourself effectively the benzene ring. Now when they measured the length of these, bonds, a single carbon-carbon bond is longer. So this bond here will be longer than this bond right here.